We're going to visualize some of that, and we're also going to show you a little bit of how you can do data sharing inside Snowflake as well. Mohammed then is going to talk a little bit about the competitive landscape, how we fit into that, because we know that's very important to all of you as well. It's one of the key things you need to know about why you should choose Snowflake. And then we'll have Q&A either for myself or for Mohammed, who will both be available for any questions that you might have. Okay, so let's start off by having a look at Snowflake in action. So what are we going to do? We're going to load data, and we're going to load some structured data and some semi-structured data, and you'll see how that kind of works out when we're loading that data inside Snowflake. I just have to restart everything because of that, so we should be all good to go. Let's start off by loading some data. So where are we starting this from? Maybe if I just make this a little bit bigger, because I don't know about you, that's kind of hard for me to read. That looks a bit better. It's a bit tiny for me, but well, I'm sure I'll code just fine. I've done this a few times before, so we should be all right. Yeah, we should go on that side. Okay, so first of all, I'm just going to make sure that I have a virtual warehouse available to do my operations. So it was that easy to create a virtual warehouse. I created a new one called Load Warehouse that we're going to use for loading our data. So later on when we do our BI, we're actually going to use a different virtual warehouse. To do that, we're going to completely separate those loads. But so far it's suspended. We started it off as being suspended, so we're not actually going to pay anything until we start doing something with that virtual warehouse. Nothing's going to happen. Now, fortunately, like in a demo, it would be really boring for you to sit and watch me upload hundreds of megabytes or gigabytes or even more data to S3. So we're starting off from the point where this data has already been helpfully loaded for me into S3, ready to go. And the data we're using today is some data about bike sharing in New York City. So there's a bike sharing scheme called City Bike in New York, and it works between different stations. And so you can hire a bike from any of these stations, ride it around New York City, and then you take it back to one of these stations and put the bike back for the next person to use it. One of the things that's really nice about this from our perspective though, is they actually publish all of their system data. So you can actually download this bike trip history, and that's the data set we're using today. It's a publicly available one that we use just for demoing, so you can see different ways of working with your data. So that's what we put already in S3. Now this is structured data. You'll see in this here, it tells you a little bit about what's inside that data, but it basically always has these different columns. So it's always the same structure, always the same information, every single trip. We know all of these things. There's a few where we don't always know them, so if they're not a customer, they just bought like a temporary pass, we don't know any demographic details about them. If they're a longer term subscriber, maybe they live in New York, and they start, we know some demographic detail, their gender, their age, a little bit about them, and how they signed up. So that's our trips data. So what we're going to do is we're going to make a table for that to live in. So Snowflake as a SQL data warehouse, you just create tables, and it follows a fairly standard syntax for doing that. So right now, I have a table, I have some data in S3, we're going to go load that data into Snowflake with a copy into command. So we're just going to actually load up all the data from 2019. Now so far, if you were paying really close attention, and you've got very good eyes, because we're on a little bit of a small screen, you'll notice we were using a small virtual warehouse to do this. So the small virtual warehouse to load the data today, even our small warehouses are pretty powerful. It took about 6 seconds to load that data. We can do a quick count query to see how many rows that was, and you can actually see this is like 11 million rows worth of data that we've loaded. So it's still pretty quick even on a small warehouse. But I am very impatient. I only have a short amount of time to demo to you today, so I need to actually step up my warehouse. I need to go, I don't want to just double up to medium, I'm going to go all the way to large, which is 4 times bigger. And so that's going to resize for me. These, like I said in my thing, most of the time it takes kind of 2 seconds to do. And you can do this while any other query is running as well. Just new queries will run on the larger size when they get submitted. Everything that was already running keeps on trucking. Same thing with resizing down. Everything that's running keeps on trucking, and then when you resize down, the new queries will run on the new size. So now we're going to load all of our data in that trips data, so all the way back from kind of 2013 onwards into there. This will take a little bit longer because it's a lot more data, but because I resized my warehouse up, it didn't take 6 or 7 times as much time. it only took about double the amount of time to load all this other data. And now we're going to just shrink our warehouse back down, because I don't want Snowflake to have to pay Amazon a lot of money when I'm not using that much compute power. So I can resize my warehouse down, and again, I will only pay the credits for my smaller size. And you'll see I wasn't kind of kidding to you. You know, we've now loaded another 70 odd million records into that. It's very, very quick and fast to do so. Now, we have some other tables as well that we can use in combination with this data. Again, it's structured relational data so far that we're using. We have some information about the stations, their location, their latitude, their longitude, the name of the station that people are picking up these pipes from. And for those who are subscribers, we have a number of programs that we're using with them, where they can sign up for annual membership, or we have some ones that are in partnership with housing associations, and that's where we'll come to our data sharing a bit later on. So let's kind of, loading data is fun. All we've done though is put it into Snowflake. Let's get some answers back out. Let's do a bit of analysis and ask some of these questions. How many trips did people take? How long did they last? What was the duration? And also, what was the distance between their start and end stations? So we don't necessarily know exactly how far they rode, because they may have gone around in a circle or come back, particularly people riding in like Central Park. They might go for a ride around the park and finish where they started. But we can get an estimation based on the data we have. And you can see, even though it's 50 million rows of results on pretty much that whole data set that we're doing, we get very quick results back. It only took about a second to run that big analytic query with all of this different analysis in there, including doing a have-a-sign calculation to work out the distance between the different points that they were starting from. So what if I wanted to use this in like a BI tool or somewhere else? Well, I would create a view that kind of maybe joins all these things together. So for my analysts, I don't want them to have to think about all the different tables we have in place. I want to make one view that I can use in my BI tool. Today I'm going to be using Looker, but as we saw in the ecosystem, you could use Tableau, you could use Alteryx, you could use other tools like Power BI. Any of those things would all be available. And we can just kind of make that view, and then we can select some data from it. And just kind of see all the information we know about those users, stations, everything else. Just resize a little bit so you can see it a bit better there. Oh, I didn't mean to hit back. It's always a hazard when you're demoing that you just kind of go to a different place. So now we've loaded structured data. We kind of present it to our analysts, and they say, you know what, it's really great to see all these trips, but I have this theory, I have this idea that actually the ridership patterns are going to change based on the weather that's in New York City, and they want to be able to test that theory. So what they've challenged us to do is then go and load some of that weather data. And where we found weather data, we found some APIs on Open Weather Map. Those give us a bunch of JSON files to go look at. Now that is a little bit different. So if you were using a traditional data warehouse that only supported structured data, you'd have to maybe write some code to actually translate that JSON into a nice table and then load it. But actually with Snowflake, we can do that kind of ourselves. Inside that, we can load it as JSON data, and then we can work with it there. Now, we're kind of good citizens. We don't want to break any of our production users who are maybe already using that. We're going to actually take a complete clone of all of our CityBike data into a database called CityBike Dev. Same thing as well, we don't want to affect any of our users, so even that data load that's going on, any BI usage, anything else, we want to be completely isolated from it, so we're going to go spin up a development warehouse, and we're going to use a medium size, because again, we're pretty impatient and we want to run quickly. I've got a limited amount of time to demo to you guys, so I've got to really make sure that I get it going as quickly as possible. So what do we have? We have these JSON files again. Someone helpfully has put them in S3 for us. You normally use an ETL tool or whatever else to land that data in S3 for you, or you can do it yourself. Either way will work just fine. To show you that I'm not cheating, so I'm not just, it's not just a table that's in JSON format that I've kind of cleverly disguised. It really is a real piece of JSON that you might get from any other API or piece of software. It has hierarchical structure to it. It has arrays inside it as well, so we have pieces where we have more than one piece of data in there. We really have some complexity in there. This is still a fairly simple one, but we handle the different levels of complexity. I didn't want you to think I was just loading, it's really a table, but it's JSON format. It's really support for that structured data. So now we're going to create a table to put that in, and here we, like our table structure is much, much simpler than it was before, because all we need to do is say, hey, we're loading this JSON data into a variant column. Basically, the structure is described inside the JSON itself. We don't have to supply, all the different fields that are inside that. Snowflake will work that out for us as it loads that data, and then we can query it. Now, like I said, I'm pretty impatient. I'm going to make my warehouse extra large for actually doing the data load, because I want it to run, fairly quickly. Mohammed is going to be, I'll be in trouble with him if it takes too long to get, my data in. He really wants to get his results nice and quickly. So we're going to spin up and load that data. Now, there's one other thing we need to do here as well. All my data in New York was in Eastern time, because that's City Bike only operates in Eastern time, so that's the time zone they're going to use for all of their data. Now, my timestamp for the weather service is in UTC, because actually the weather service, we're just looking at the New York portion of it, but actually they provide, weather information for kind of cities all over the States, all over the world. We need to translate that time zone as we load this data so that we're actually talking about the same time when we join up our data later. You can convert it later, or you can convert it now. It kind of is up to you as to how you want to do it. But I just want to show you that we can actually do a little bit of translation of that data as we load it. And that's pretty common for JSON data, is pulling out something like a timestamp, pulling out something like a key ID into a column as you load it. Really common pattern that lots of our customers use. Now we've done our data load, we can shrink our warehouse back down again so we pay as little as possible, and we can see what we've loaded in terms of our data. You can see now we've got 95 million rows of weather data. There's all this big blob of JSON, so there's lots of that kind of stuff going on there. And let's kind of query it. And so far you're probably thinking, well, what's the kind of, how does this work? Like, you've just shown me, okay, well, you've given me back the same JSON we had before in that column. I can't really, what kind of analysis can I do? How can I average this, or how can I ask analytic questions of it? Well, what we've done is we've actually added an extension syntax to SQL, where you can use this colon syntax to go say, okay, get city.name, so go grab the city key, then the name key underneath that, and then we'll cast it to a string because we want to use it as a string. We have the same kind of thing for dereferencing arrays, so grab the first element of the weather array is what these square brackets are doing for me here. And then let's find out when it was snowing in New York by querying this data without having to supply any extra structure. So here's all the times, actually here's the first 100 times in our data set that New York was snowing. We can find out the answer to that question. Now, that's a pretty simple way of querying. We can do more complex things. So you might have seen here, you thought like, well, that's fine if I've only got one element in my arrays, but what if I've got lots and lots of data in these JSON arrays? How does that work? Well, we have this special thing called flattening data that we're doing here. And so now I live in the UK. A lot of people think I'm from the States. I'm actually not. I've always lived in the UK. I just have a funny accent because I have a Canadian wife and I work for American companies. And my best friend's American, so it's just a whole world of American influence on the way I speak. But let's say I did decide I wanted to move to the States. I want to find which of the cities has the best weather conditions for me to live in. What's the kind of good place for me to live? I picked a few cities from this data set that I think might be interesting to go think about living in. And I wouldn't mind snow, I don't mind clouds. I'm from the UK, we're used to rain. All of that stuff is kind of fairly normal to us. I'm a little more concerned with some of these things like haze and thunderstorms, and smoke is deeply concerning. I probably don't want to be anywhere that has a significant amount of smoke going on there. That's kind of pretty concerning to me. I don't want to stay there. So having had a look at this, I kind of think, I could live maybe in Seattle or San Francisco, or maybe even New York would be maybe good cities for me to live in. Maybe not so much living in Miami with all its thunderstorms going on there. I'm a bit more worried about New York than I was before as well. I thought it was going to be nicer weather there. So that's a little bit of analysis we did on there. Just a quick kind of thing. So I'm happy as a DBA that I've done my job right. I want to shift that stuff back into production so that people can kind of see what's going on. So we're just going to do the same thing we did before. We're going to clone it back into our production database. So now it's available for anyone to make use of. Now I've done that, I can actually get rid of all these resources that I had before. So I get rid of my warehouse, get rid of my database. I don't need it, I don't need to pay for it anymore. And now I'm going to use kind of some advanced SQL features. I'm going to use common table expressions. I'm going to use UDFs that are going to convert the degrees Kelvin in my data source. Anyone understand degrees Kelvin? I mean, like, people have probably heard of it, but if I tell you it's 290, what does that mean to you? We're going to use some user-defined functions to convert it to Celsius for me, because I'm from the UK and I have no idea what Fahrenheit means, but I have a lot of colleagues in the States, they're going to want the temperature in Fahrenheit because that's what they use there. So we're going to create this common table, create this secure view that we're going to use with our analysis in there. So we're going to do that kind of thing. And then I can query this, and really now what I've done is I've made a view that's joining together based on the time, the weather in New York, with the trips that are being made, and I kind of can do so. Let's have a quick look at some of that data. And I can just query this as if it's any other kind of SQL table or SQL view. So all of my other tooling will understand that in the same way it does, even though under the hood it's actually querying inside this JSON. In actuality, when we look at it from our tooling perspective, it looks just like any other view or table would to make use of it. So now we can go have a look at that in our BI tool, and hopefully that survived my restart. So now we have Looker wired up, and this now looks much prettier than looking at my tables of SQL inside Snowflake. But I'm okay with that as maybe the DBA. You guys, maybe if you're business analysts, you want something more like this. We've got Looker wired up here. We've mapped the locations, the locations inside Looker. We've set up some measures and dimensions so we can actually kind of query this data and present a bit of a view. And I've been using development mode because I've been making changes to this morning, so I need to commit those changes ready for everyone else to make use of it a bit later. But I can kind of see all this data. I can even use this to kind of drill in or whatever else on my different trips. And I can also test that theory I had that trip volume kind of correlates with the weather a little bit. Now, if I had a data scientist, they would want to do a lot more complex testing with things like variance and looking at ANOVA and t-tests and all these other kinds of statistical things they might do, or they might do something like a regression model to see how much of the explained effect is due to temperature. But just looking very simply at my graph, I can see from my exploratory data analysis point of view, my theory that when the temperature is warmer, more people ride their bikes seems to kind of bear out that there is definitely a relation there. When we have better weather, we're likely to have more trips. I might then make sure that there's more people who are doing movement of bikes between high demand and low demand areas. So using the heat map, I might see that not so many trips start in New Jersey. There's a few kind of stations over on the Jersey side of the bridges, but a lot of trips end there. So more of them end there. So we're going to need to grab bikes from those locations and move them back into Manhattan where people are kind of using them to ride over the bridge. So as I see the weather is going to be improved, I might then actually have to get some more staff, get some more trips going over to Jersey, grabbing bikes and bringing them back. Obviously there's some more detailed analysis to be done here, but my initial kind of thought is that some of these things are going to be useful to that as doing analysis. So we've loaded our data, and we've also used Looker to visualize that data. The last thing I'm going to show you is just a little bit on data sharing, so you can see how we're able to share that data securely with our partner organizations. So what we're going to do is, I've got a little bit less time than I would like to have here, so I'm just going to show you the setting up side of data sharing. We'll simulate it from my account rather than logging into theirs. It works exactly the same way. But what we're going to do is we can actually publish this data out to our consumers. So what we're going to do is we're going to create a share for sharing our data, and then we can grant access to our views and we can see it. Now, this will work just fine. We've granted them to use that view. That means everyone that we share with will be able to see all of that data. That's probably not quite what we want to be able to do, so we've kind of got a little bit more work to do. We have this little security table here which describes some rules for who can access what data. So you may have seen when we looked at the programs earlier, there were some that were run with these housing associations. We have a couple of them who we're trying to share data with. What we want to do is use this security table to control who can access which accounts. So what we're going to do is we're going to add those accounts to the sharing first, so we can go make sure they're able to see that data. And then we're actually going to set up a better version of that view so they only get access to their data. So what we're doing here is we're only publishing some subset of the data. We're using this special current account function that tells us who it is that we're sharing data with right now. And we are actually filtering, using that filter to get just that data. So when we're querying this view as us, as the data provider, we can see everything. So we can see trips with any type of membership. All of these different types of memberships here at the bottom, we can see everything. Now, if we change over to pretend to be one of these other users, and it would work the same in their account too, what I can do if I go run this now is I will only see trips that are from these particular housing associations. So now you can see they're all NYCHA program types that we have in there. So either free usage or members. And similarly, this works not just for queries like this, but for analytic queries like this one, where we're looking at which programs do we actually see people using the most. All of those things will work just fine as that different user. So we can change who we are. We can simulate it from our provider account, but it will work the same from their consumer account. Mohammed? No problem. Oh, I hit the wrong button.
Do you want to have the Q&A session before the competitive part? I don't know the technical people in this part of competitive will be interesting for everybody, so if you want to ask a question before, I can answer. Up to you.
Those who want questions now, raise your hand.
Okay. Thank you. So, I will start with this slide I already showed this morning about the analyst recognition. On the Gartner side, you will find all the data platforms, so the on-premise platforms, the data warehouses, databases, and also the Hadoop platforms. So it's a mix of all those. And the Forrester is mainly on the cloud data warehouse. And I will emphasize on this space in this competitive analysis. So I already told you this morning that we are cloud agnostic. We can rely on AWS, Azure, and Google. So these are our partners, but these are also our competitors because each of them have tools doing kind of same thing as Snowflake, not exactly the same, and I will explain you the difference. So, the bottom line is the following. We are, as I said this morning, the only data warehouse built in the cloud. Okay? So, even Google, AWS, and Azure, their solutions were before on-premises solutions. Okay? They took them from there, SQL Server, for example, or Paracel, etc., and they modernized them and put them in the cloud. So, they are not optimized for the elasticity you are waiting from a cloud data solution. This is very generic, so I'll go a little bit into details and comparing the three of them to Snowflake. Microsoft, they issued recently a new generation of their Azure SQL Data Warehouse, which is, of course, and hopefully for them, more performant, etc. But first of all, some issues remain. So they cannot separate the different workloads. Okay. So all what I explained this morning in the benefit of having people doing data science in parallel of others doing analytics on a specific view, on others doing BI analytics on another view, while you are loading data continuously in real time, you cannot do this. So you will decrease the performance if you are launching maybe 3 or 4 algorithms with Python or Ajax, and your analytics team will not be able to work. So this is very important. So the compute is attached to the data, and also all the elasticity of the instant resizing we described in Snowflake is not possible with Azure, the SQL Data Warehouse, because each time you need to add new clusters, you need to copy the data. Okay? So this is manual, complex, and it added costs. Also, SQL Data Warehouse reduced premium storage from Azure, and it costs almost $120 a terabyte per month. Our cost is at 23. Okay? So as soon as your storage will increase, you you will see a very heavy difference between the prices. And also, as I introduced it on the on-premise solutions, as they were migrated to the cloud, they are not SaaS solutions. You can qualify them like PaaS solution, platform as a service. So you still need to maintain the platform, to have the upgrades, the maintenance, etc. So a lot of maintenance around this. I will not go into detail into this slide, but here you have feature by feature the comparison between Snowflake and SQL Data Warehouse. So you will see how we differentiate. For example, what Declan just showed on the JSON with the weather that we reported and jointly acquired with our data in the structured data table is not possible. So you cannot ingest immediately and natively JSON, XML, Avro, etc. And when you look to the data market today, IoT is semi-structured, e-commerce is semi-structured, social media is semi-structured, and even internal applications for sometimes like mobile, etc. are semi-structured data. So if you need to have all your data in one place and to really create a single source of truth, you need to handle this natively like in Snowflake, and we are the only vendor doing this. So we have other examples. I already talked about pricing and administration also. Concurrency is very important. Usually for the BI analytics data warehouse space, people are doing capacity planning. Okay, you need in the advance to know which capacity you will need, and there are events that you cannot prevent, like the Monday morning or the Sunday morning rush hour, or the end of a quarter fiscal closing, etc., etc. With Snowflake, you have the auto-scaling. Okay? As soon as we see some queues happening, Snowflake will create a second cluster to handle this way and load balance the load between those different clusters. You can create a third one, a fourth one, etc. And then, as soon as there is less load, it will decrease and kill these clusters. So you really pay as you use, and you don't need to do capacity planning. We will handle it for you automatically by the product. AWS. AWS was the first in this market, the cloud data warehouse. Okay, so their tool is called Redshift, but Redshift is really having a lot of problems today. First of all, it's, as I said, the legacy on-premise environment shifted to the cloud. So this is something common for all their solutions, as I said. And you cannot decouple storage from compute. So you will be using Redshift for 6 months, 1 year, and then you will realize that if you need more data, you will need also more compute and to pay for it because they are not decoupled. And same thing, if you have few data but a lot of use cases, you will need to pay more compute and more storage. So this is a price problem, but also this is a scalability problem. So today they resolve one issue, which is scalability upscale, I would say. But to scale down in Redshift, you need to stop Redshift, decrease the number of clusters, reload the data, and restart Redshift. In the best case, it takes 30 to 45 minutes. In Snowflake, it's automatic, instant, and you don't need to handle this. It's done automatically according to the load you have. So, in Redshift, you have a lot of management. When you start using Redshift, it's only about the management of the platform. As soon as you have a lot of data or a lot of use cases on Redshift, you will need to do vacuuming. This is something very recurrent in all Redshift customers and taking a lot of time, even hours. So if you cannot work on the platform for hours and you're expecting real-time analytics, it doesn't fit. One important thing, as I said, they were the first one in this space before Snowflake came. Today, more than 60% of our revenue for the last year was replacement for Redshifts. So unhappy customers with Redshift moving to Snowflake. Decreasing prices and also increasing, of course, performance and scalability and flexibility. The last one came in is in the region, is Property Finder. We signed 1 month ago. We started the migration a few days ago, and they are leaving Redshift because they were completely stacked. The users were leaving Tableau because they cannot have the dashboards at real time, and they were doing Excel again like 10 years ago. So this was not acceptable for a company who is still growing in the region. The last one is Google. Google is massive, as everybody knows, but Google provides what we call BigQuery. BigQuery is a very performant tool in terms of query, but has a lot of weaknesses when we talk data warehouse. First of all, it's not a data warehouse. It's not a truly data warehouse. The name is BigQuery because it's a BigQuery tool. And it does not implement a lot of key capabilities you need when you are talking database and data warehouse, like multi-statement transactions, consistency, etc. Second, BigQuery is a black box. You launch queries, and you don't know when the result will come. Usually it's performant, but sometimes it's not performant, and you don't know why. And you cannot influence on this. It will be executed on a Google farm somewhere in the world, and you don't have any access to any information when it's executed. Except the case when you are able to pay a flat rate, and you will have your dedicated resources, and this flat rate starts at $10 per month. So it's really a huge amount, depending on the size of what we need to do. When it comes to complex workload, by complex workload, we can just have the example that Duncan just chose with semi-structured data, query jointly with structured data. That's all. I don't talk about data science. What we saw in the different benchmarks in the market is that BigQuery is not performing very well because it has concurrency limits when it comes to complex workloads. Finally, the pricing is problematic. You heard Asma this morning talk about the simple pricing in Snowflake. Snowflake is very easy to know. Storage, $23 terabyte per month, and it's compressed terabyte. So if you have less than 1 terabyte in your data, you can be sure that you will pay maximum $23 per month for this. So it's very cheap. For the compute, we are pricing by second. Okay, so you use a virtual warehouse like Duncan showed to execute queries, you will pay 3 minutes if you use it 3 minutes, and that's all. Okay, and then it will be suspended automatically, and it will be auto-resumed when you execute a new query on it. So when we modelize the activity on Snowflake to know the pricing, it's very simple. We discuss the different workloads. Okay, one for data loading, one for BI, one for data science, one maybe for sharing with the partner company, etc. And each one, how many hours it will be used. So usually you will say, okay, this one will be used 8 hours. I will tell you, no, it will be 4. Because of what I just described, the auto-suspend and the auto-resume. You are charging only when you use. So if you open the service with Looker or with Tableau or Power BI 8 hours a day, be sure that with Snowflake you will consume maximum 4 hours. So this is the second optimization. And Duncan talked about the sizes of virtual warehouses. He showed you that we can start with a small, upgrade to a large because we have large queries, then go to medium, etc. So we size those compute nodes like t-shirts, from extra small to medium to 4x large, so from 1 node to 120 input. And what we charge is a credit is the consumption of extra small in 1 hour. So you go to small, it's 2 credits, medium, it's 4 credits per hour, etc. And at the end, you have the number of the credits you can use on the year. It's very simple. BigQuery is very complex. You have a lot of parameters. You have some notions of slots additional to the gigabytes, etc. And the most important thing is that there are quotas. So there are quotas on concurrency, number of users at the same time, number of slots, number of queries, etc., etc. There is a list of 10 quotas, which is public in their website. So it's really complicated to know how much it will cost you. Okay? So that's all from my side. you have any question, technical, commercial, use case, anything, we are here to answer.
You didn't mention Redshift Spectrum in the comparison.
Yeah, I mentioned the main three competitors. This is also a weakness of AWS because they need to have three tools, Redshift, Athena, Spectrum, in order to do almost what we are doing. So when you talk single source of truth, etc., it's not true. They have at least three tools to answer it.
I have a concern regarding firewall issues and virtual private clouds, whether in Azure or Amazon. A lot of customers still feel secure within their firewall limits and do not want their systems to be accessed publicly. So what's your deployment model?
So we are only SaaS-based, so we are only in the cloud. All the data is encrypted 100%. From the moment it leaves the data source, it's encrypted. It remains encrypted in our storage. It's decrypted when there is a query to execute the query, and that's all. We don't have access to your data. Okay? So when we sign a contract, we have a DPA. It explains exactly what are your role and responsibilities, what are our roles and responsibilities. We never have access to your data, which is encrypted. And for additional securities, some customers need to re-encrypt the data at their own whenever they want. So we have a specific edition called Business Critical, not the enterprise one, but Business Critical, which is just an additional feature. And you have three levels of encryption keys, one provided by the cloud provider, one by Snowflake, and one by your customer. And you can re-encrypt your data at any level all the time. So we have, as I said, 3,000 customers. We have big logos like Netflix, like Morgan Stanley, JP Morgan. So you can imagine if those banks, investment banks, put all their data within Snowflake, that is something very secured. The first employee in Snowflake after the founders was a chief security officer, because we are handling data in the cloud. So if you have a breach, if you have a problem, we are dead as a company. It's finished. No one will trust us. So all the effort. Capital is the biggest customer.
They had a breach and they lost millions of customers.
With AWS, yeah, they had a breach with AWS. But we are having our security layer on top of AWS, which is much more efficient.
Okay. So you cannot be within the customer's data firewall.
No.
How about extracting data from on-premises data sources behind the firewall, or even cloud RDS instances behind the firewall?
Okay, explain this part, yes.
So one just last thing on the last one. You can do with, again, the Business Critical Edition, you can do private link access in AWS between Snowflake and your VPC in your account, yeah. There's also a network control policy, so so we use that for like our internal access. If I want to log into the special Snowflake accounts to do things with our partner accounts, that's part of my job. I have to be on our VPN because there's a network control policy as well that enforces for access to those Snowflake systems. I have to be on that. So there's a few extra features as well that work in that space. With regards to, I've lost track of where my other question was going. This is on-premise, ones behind the firewall. Yeah, so that's going to depend on the ETL tool that you use to load data. So from our point of view, we don't touch those external databases, right? That's not a Snowflake function. That would be a function of whatever ETL process you use. So I know for most of the ETL providers we work with, they provide some sort of option for an on-premise connector that then connects onto their service if they're cloud-based, or if they run on-premise, like an Informatica or a Talent will run on-premise. You run those on-premise, they just need to be able to connect to the Snowflake service.
So we need to allow them access to the Snowflake?
Yeah, that's right. So you'll need to allow access. Everything that we do goes over HTTPS to the Snowflake service, and also we'll need access to the blob storage or S3 in that region as well, because that's where we store query results, and that's also fundamentally where the data is actually being placed when you load it. So we provide, there's a whole page in the documentation about connectivity issues and what you need to whitelist and how all that works. We take it very seriously, so we do things like OCSP to make sure that actually we're not being man in the middle and all sorts of other stuff too, so you have to, if you have particularly paranoid security people, then you'll need to kind of go through all of that.
And the data migration tools you mentioned, SSIS, is SSIS possible?
So you can use SSIS. Generally with SSIS you have to be a little bit careful about how you use it, because with the way you load data into Snowflake, you want to do a bulk data load. So you want to have a big chunk and then you want to do copy into, because of the way we store data. If you use SSIS in a naive fashion, it will try and do a lot of individual single row inserts. It'll work, it'll just be amazingly slow, it'll cost you a lot of money, and it will not give very good storage usage for us. So you have to kind of drop files, and then you can have SSIS run, SnowSQL would actually put and copy. Those will work better. If you try and use it in a naive fashion, just connect over ODBC, it'll do all these single row inserts. Don't do that, please. You'll spend loads and loads of credits and you'll be very angry with me, and I don't want that.
So the best practice is to load it on some big data storage and then use a copy into.
Yeah, exactly. So we can either, if you use a put command, you can load it into what we call an internal stage that runs inside our AWS or our Azure account. We also will make sure the data gets encrypted if you use that, as part of our always encrypted strategy. Or you could load your own data, load it into an AWS or Azure location you control. And actually, if you do that one, you can use it across your different cloud providers as well. It doesn't have to be, even if you're already in AWS, you can load from Azure, same the other way around. But generally, you're going to be loading from the same cloud, same region. Yeah. Any other questions? Someone must have. I've answered all of your questions, you're super happy, you're all going to go sign up for trials straight away. That's actually a good point.
If no one else has questions,
Please go ahead.
That's a lot.
Well, we can take at least one or two more, I guess, and then we'll, I don't know when we're supposed to wrap this session up and move on to the next one. So what I'll point out as well, though, is you have trial.snowflake.com, which you totally can't read, because it's trial.snowflake.com. Sorry, it's hard to make the screen bigger. And you can sign up, you get $400 worth of credits, so on Enterprise that works out about 133 credits. All the stuff I did today is about 7 credits worth of usage, maybe a bit less. To give you an idea of, you could do lots and lots of things with Snowflake in that time.
Do you use columnar indices or columnar compression?
So we have a hybrid row columnar format that it's a bit like PAX. If you're familiar with that literature, there's a Sigmod paper you can get. So if you look for 2016 Sigmod and then like Benoit or Snowflake, that will go into detail on how we store it. But basically, any individual row is going to be stored in the same file, but inside those files, everything is stored in columnar order. So all the IDs will be first, then all the date stamps, and whatever else you have column-wise. So we use that format. We keep statistics on it as well, so we use those for pruning, so we only read the micro partitions you need to answer a query. And then when we do that, it's columnar, so that when we're processing a lot of these, we can kind of, we do vectorized execution on this as well. Because one of the other founders was involved with, if you're familiar with it, MonADB and the successor to it, Vectorwise. So a lot of the stuff is done through vectorized execution, one of the reasons why we're able to do these huge analytic queries so quickly.
Yeah, just to understand.
Please.
Just to understand the mechanism of working with Snowflake. When you run a query on the virtual data warehouse,
yep.
You are grabbing the data from the sources directly, then
No, so well, generally we're grabbing it from the centralized storage, right? So data is generally copied into Snowflake, usually mediated through some sort of ETL process. As you saw in the data lake slides we had earlier, you can do external tables. And in those cases, yes, we're going to kind of query them as, we're going to go grab them as they're being used, but they're typically already going to be in S3 or something similar to that for those external tables. But by and large, yes, we've already loaded that data in. So we work with a variety of ETL partners. Some of them will do more like batch load, so it'll be like hourly, daily, something of that nature. There are a number we work with that do more of a continuous replication. So Attunity or HDR will work in that way. And that will push changes much more rapidly. So particularly within minutes of latency to bring them in.
After the computation done, what happens to it? It remains the same.
Yeah, so basically one of the reasons that so in the centralized storage, those files are going to stay there until you tell us to drop the table or truncate the table or whatever else to say, I no longer need this data. we'll retain it. We also will keep track of time travel, so basically we version the table as we go through. And as you make updates or you add new data or whatever else, that's all fine. You can always go back within your time travel window, so the default on all of them is 1 day, but in Enterprise you can set it to be up to 90 days worth of time travel on your data, so you can actually just go back in time. It's also super cool for data science type use cases. If you're a data scientist and you're like, I want to know exactly what we knew about this customer 30 days ago because I want to do some sort of churn modeling or some sort of survivorship type analysis, some sort of predictive. There's a few use cases that will work in the same way. You could actually use time travel, so you can be like, I don't trust any of you people to tell me what we knew about that customer 30 days ago. I'm just going to go by exactly what what was in the data warehouse at that time. And you could actually join that against the current table to get your target features, so whether they've churned or if they've upgraded to a different plan or whatever your kind of target variable is. You can do those kinds of use cases too. So in that case, we keep the intermediate steps of the data as well.
Yeah, and this kind of snapshot is our way to track the history or change data.
So for change tracking, I mean, you could use SQL set operations to do the difference between tables at 2 points in time. But more likely, if you want to do like a change data capture type use case, there's actually a feature in Snowflake called streams that will generate on a table basically the change records. So create a special kind of virtual table, as it were, of all the changes that have been made to that table, and then you can consume that. There's another feature called tasks that will let you basically consume that on a schedule, and the task will only run if you can set a where clause to say basically only run this task if there's anything new to process in that stream to kind of do this kind of processing of data inside Snowflake. So some customers use that, some customers use their ETL tool, so something like an Opportunity actually will do change data capture on the source database. So it depends on what you're using as to what's going to be the best way of doing it. We obviously will support either. The stream is the native functionality, but some of our ATL partners will do some of those things for you as well. So it depends on what you're using is what's going to be the absolute best way of doing it for you. But streams and tasks is a very nice capability that you can use to build these kinds of change processing pipelines.
For IoT kind of use cases, if you want to ingest data into Snowflake from IoT, this will require small insertions and small updates at a time. They will not necessarily come in bulk.
Yeah, so I mean, like small is a relative term. When we write a micropartition, that's going to be 16 megabytes compressed of data. So typically, if you have a large volume IoT, like you can be generating hundreds of megabytes in a minute or two. So it's, we're typically going to be operating on that minutes range for those IoT devices rather than like we're not going to be sub-second or anything like that. No, that's not. That's not something we handle today. Is doing those kinds of cycles. So one of our customers actually, big migration from Teradata. They do a lot of IoT use cases. They're now referenceable, like as of yesterday. So this is great. I can talk about it. Is Micron, and the reason why I like to bring them up as well, not only are they doing these great use cases in IoT, but they're able to do a migration start to finish from on-premise Teradata in 111 days. Which, like, Micron is huge. This isn't like a simple migration will be much faster, but they're a really big, like, Teradata migration, 111 days from start to finish. That's their thing that on us, out there. So they're a really nice use case, and a lot of the data is actually sensor data, IoT, things around like manufacturing, process monitoring, and these kinds of things. So they do a lot of that kind of thing.
How do you manage the data egress costs around that? What do you tell customers?
I mean, so like replication fundamentally is a feature you only need if you need it, right? Yeah. We don't say every customer has to have data replication. It's only in that business critical edition and above. So there's some proportion of our users who will want it. It will never be every single customer. If you want it, you're usually willing to pay for it because it's cheaper than the alternative, right? So either you're using it for your backup and your recovery objective, and that's why you're going to pay for it, or you're using it because you want to have a queryable replica in another region because you're doing enough query load there that it's cheaper to replicate than it is to do the queries. You get better performance profiles, and thus you're willing to pay for that way. So from a value perspective, I would very much say it's only if you need it and want it, you want to have those egress costs. Is there anything else you'd say, Mohammed? I mean, that's my kind of thing. It's there if you need it. It's not.
But how do we build in this Do we pay you for the data egress costs, or do we get a separate bill from Amazon?
So no, you won't get a separate bill from Amazon for using Snowflake, right? If you load from your S3 stages and stuff, yes, then and that's cross-region, then you'll get a bill from Amazon for that, like you would for any other data that's in S3 that's being read. But if you keep your usage within the Snowflake service, including with replication, you will just be billed by us. That's it.
And you will have the egress costs.
We will manage that as part of your storage costs, yeah. So we will charge you a wrapped up price for everything to do with your storage. We don't give it as a big, we don't try and make a lot of money on that part of the operation. Like it's against our model, right? We want to make it cheap and easy for you to put all of your data in Snowflake. Well, one of the ways we do that is by not charging a big premium on storage, right? If we did, then you'd say, but it's cheaper if I just store it in S3 and use external tables. And then, every single engineer in the room will cry because you just made a poor technical decision driven entirely by cost measures, and we're all sad about that. Yeah, so single Snowflake account.
Multi-cloud, I have to have multiple Snowflake accounts.
So, you will, but there's a feature we have called organizations that lets you manage those different Snowflake accounts. But yes, fundamentally a Snowflake account is like the URL. So mine is IE demo EU West Snowflake Computing. That is explicitly in the EU West. So that's in Ireland, AWS. So yeah, it's specifically separated to that. But now we have the replication features, and now we have organizations. Those kind of add a structure on top of that lets you manage multiple accounts.
Similar to consolidated billing in Amazon, for example. No.
Yeah, similar. Let's say similar is fine. For today.
So I've faced an issue in a use case where I was using Power BI for data visualization, and the customer had data lake in S3 and Athena. And this only allows for data imports from Athena into Power BI, so I have to copy all the data into Power BI to be able to generate the reports. But some data sources allow direct querying, so instead of storing the data in Power BI,
you just send the queries. Yeah, Snowflake supports that.
Yeah, and so you support that for Power BI.
That's right.
That's great. So even for external tables?
As far as I'm aware, for everything. From our perspective, external tables, you only know it's an external table if you go peek under the curtains.
Because I've tried with Redshift Spectrum, and it worked for Redshift, but when I tried to query Redshift Spectrum table, it generated query folding errors.
And so you make Mohammed's point very neatly for him.
Yeah.
There you go, don't believe me, believe him. He tried it.
Drivers and connectors for extracting data from Snowflake, whether in R, Python, .NET, do you have that?
Yes. JDBC, ODBC. Go.
Okay.
Some others. Native connectors for a number of BI and ETL products as well. The partner ecosystem is so large, it's very hard for me to keep track of all of it. It's literally my job. We're always adding new things.
So you mentioned that you have one central storage where you put all the data in, and you meant for all the customers, right? So all your customers are...
So each Snowflake region has a centralized storage area, which is S3 or Azure Blob Storage. Yes, and all data is stored there.
So how do you perform isolation between different customers' data?
So we do that based on your encryption keys are completely different. So there's a whole long security page about this, which I will not get into too much detail because it's very easy to say something that sounds correct but is ever so slightly wrong. But the very short version is everything is encrypted with different encryption keys, and there is a key hierarchy of keys that is per customer. And so the virtual writers will only have access, A, logically they'll only have access to it because of the way our code works, but B, also encryption key-wise, they will also only have access to the things they're able to decrypt because they will only have certain encryption keys available to them at the time they are your virtual warehouse. Yeah, there's a whole page on it. And you can also do customer managed keys as well, but then please take care of your encryption keys, otherwise we won't be able to read your data and you'll be very sad. And of course, people will then be like, hey, can you do anything about this? It's like, no, we cannot. I think we need to wrap up now, right? So last question, and then we're done.
So when you mentioned virtual data warehouse, and in the code I saw database and warehouse. I'm
Yes,
not
that's
sure
right.
what's the difference there.
So database is just like a database in any other system. It is just an organization for storing a bunch of tables. So databases contain schemas, contain tables and views. That's what they contain, right? That's the data.
Okay.
The warehouse is the compute.
Physical data.
Yeah, so the data.
Okay.
The warehouses are compute.
Oh, okay.
So they operate on that data. They're completely separable. So I can control by my role exactly which compute resources that you have access to and which data you have access to. And they can be completely disjoint or completely overlap, it's however I want to design it.
Okay.
So, I can say anyone who's an analyst has access to the analyst warehouse, but you have to be, if you're a security analyst, only the security database. If you're a business analyst, if you're a marketing one, you get access to marketing data. If you're in finance, you can see all of finance and marketing, however I want to design it.
Is there a limitation of the number of databases I can create per account?
There's a soft limit that can be raised, but it's more than you will make.
Okay, how much?
It's thousands, I mean.
Thousands, oh.
It's very large. Our largest customers have like a lot of databases. This is why I'm like, it's more than you will make. It's a pretty big number. And really, it's only a soft limit, right? You can contact support and they'll raise. So if you get a database creation error, it'll be like, okay, contact support and they'll raise your soft limit. But actually, we proactively monitor these two, so you shouldn't even hit it anyway. Our operations team should know this, and they'll actually bump your soft limit up a little bit anyway. All right, I think we have to wrap up there. Otherwise, you're not going to make your next session. So thank you very much.
For those who want to have some books here, Cloud Data Warehousing for Dummies, and also data sharing, if this is something that interests you.
Thank you. It was a pleasure meeting you.
Thank you very much.
I'll be in touch for sure.
Thank you. Yes, please.
Thank you.
This is fine.
I will have show here, but you can take it.
I have more.
It's not mine. This one.
Yeah.